Welcome back, folks, and in this particular video, let's talk about scatter plots and correlation. All right, let's start off with scatter plot. So what's a scatter plot? So a scatter plot is basically a way of visualizing relationships between two variables. The scatter plot contains two different variables. Okay, you have what's known as the explanatory variable, which is basically your x variable. And it gets this name explanatory variable because it's the reason, like, as we change x values, the y value responds to those changes. So it explains the changes in the y variable. So the x variable, we call that the explanatory variable, and the y variable is called the response variable. So as I said before, as the x values change, the y changes in response to those. Okay, so just a little bit of vocabulary there. Just think of, you're going to hear me a lot throughout this lecture, more so refer to them as x variables and y variables, but I did want to provide you with that terminology in case you come across those in a different setting. All right, so basically a scatter plot is just a plot of a bunch of ordered pairs. So when it comes to scatter plots, we have data represented by these two variables, and we just simply go and plot them on an xy plane. All right. Note, when we say plot, for example, the age of a person versus the number of hours they sleep, they get, we always interpret this as the y variable versus the x variable. So anytime somebody asks you to plot this versus that, the first thing they say is indicative of the y variable. So in this case, the example I gave you, the age of a person versus the number of hours of sleep, the age of the person is the y variable, and the number of hours they sleep is the x variable. Okay, so I wanted you to make sure that you're aware of that notation. Okay, let's see here. So then, once we have these scatter plots, right? So once we have a scatter plot, we have all of these values plotted on a plane. We may be interested in the direction or the pattern that the scatter plot is displaying for us. And so what do I mean by that is that this term is called association. So association is just the relationship between the variables on a scatter plot. So what I mean by that is, look at, let's say for instance, as the x values increase, as we go to the right on the x-axis, if we start to see that the y values are going up, so meaning, just think of a line with a positive slope, right? A positive slope means as the x's increase, so do the y's. Okay, and so we call that a positive association. If the x values increase and the y values increase, we call that a positive association. If the opposite is true, think of a line with a negative slope. All right, this means as the x value increased, the y value is decreasing. We call that negative association. So I just want to write these down for you. So we have positive association, and then we have over here negative association. Okay, and then if there's no discernible linear pattern, okay, so the key for this course is that we're going to be focused on the linear patterns of our scatter plot. If there's no discernible linear pattern, then we say that there is no association. Okay, so if they don't appear to follow a line, or if there appears to be no pattern at all, we say there's no linear association. Okay. So for example here, what I have here are a few scatter plots. And what I want us to do is I want us to go through, I got about 5 of these, I believe. Let's go through and let's identify the association, whether it's being positive, negative, or none. Okay? All right, so let's look at this first one over here. I'll call it A. And as we look at these, so the red dots there, each individual red dot corresponds to a data point, an X and Y data point. So as we look at that, the trend happens to be, as the X's increase, it seems that the Y values tend to go down as well. So we would say that this exhibits a negative association. Okay? And in fact, I would say if we call this graph B, I would say scatter plot B also has a negative association. But notice the difference between graph A and graph B. Notice that graph A seems to be following like a tighter line and graph B is more spread out. Keep that in mind. We're going to talk about what's known as the strength of the association. So we call A strongly negative and we call B weakly negative. All right, moving along. I see here, let's see, plot C or scatter plot C. What do you guys think? Would that have a positive association or a negative association? This appears to have a positive association. Okay. And then part D, that also seems to have a positive association. But with this graph on D is notice how it's not really following a straight line per se. It's like a curve or a bend to it. We'll talk about that in a second, okay? So it's showing some, excuse me, some linear association, but that bend in there is weakening the strength of the linear association there. And then this last one, part E, this scatter plot, there's really no discernible pattern at all, right? It's just like a cloud of points, right? So when you see something like this, there's definitely no association. Okay, so I'm hoping that helps you guys understand what we mean by positive, negative, and no association. Linear association, okay? All right, so here we're going to touch on a little bit of what we saw. So notice that some of the scatter plots appear to follow a, I misspelled that, a straighter line than some of the others, right? So some of the lines were more straight if you were to look at the data values than others. This is due to the strength of the association. The stronger the association, the more closely, this is bothering me. The more closely the scatter plot looks like a line. So the stronger the association, the more compact the points are and the more they resemble a straight line. However, the more scattered out they appear, the weaker the association is. Okay? And so what I want us to do really quickly is we're going to go back to the scatter plots we just looked at, and let's just go through and identify if the association is weak or strong. The linear association, keep that in mind, linear association. So we've kind of already talked about this, but when we go back to examples A and B here, scatter plots A and B, we can definitely tell that A has a stronger negative association compared to B. So B has a weaker negative association. Why is that? Because if you look at scatter plot B, its points are more spread out, but it still has that overall downward trend. It's just that it's more spread out. And similarly for C and D, they both have positive association, but we would say that positive association for C is strong, because that's pretty close to being like a nice straight line. Whereas for D, yes, they're going up, but they're going up in this, like, it's almost like an exponential if you remember your college algebra days. So we would say that this is actually a weaker positive association. Why is that? Keep in mind, when we talk about association in this class, we're talking about linear. So there is a really strong exponential type of relationship there, right? But there's not a really strong linear relationship there. So there's some, but it's not that strong because of that curve, right? So linear means straight line. All right, and then E, there's no association, so there's no need for us to talk about whether it's weak or strong. There's really no association there. Okay, so as you go through, so it's kind of subjective if you think about it, right? To look at a graph and say, I don't know if you're weak or strong, kind of in between. Well, thankfully, there is a statistical measure that will quantify the direction and the strength of the linear association between two variables. It is called the correlation coefficient, and we give it the symbol R. So correlation coefficient is a numerical, it's going to be a number, okay? In fact, it's going to be a number between -1 and 1. Okay? And we'll talk about more about that in a second. But how do we calculate R? So R, it's a bit of an interesting formula. It's not too bad. But what we do is we do 1 over n minus 1. So n represents the number of data values that we have, the number of points. So n is the number of points, the number of those xy pairs that we have, okay? So we do 1 over n minus 1 times the sum of, and what we do is for each individual x value in our data set, we take it, we subtract away the mean from it. So if you guys remember way back in the beginning of the course, that was a deviation. And then we divide it by the standard deviation of the x values. Okay, so we do that for each x value, and then we multiply it by, and we do the same thing for the y values. So you do each y value minus the mean of the y, all the y values over the standard deviation of y variables. And we're multiplying these two things together, and then we're adding up all of these pairs of products. If that makes sense. We're adding up all of these products. All right, and then we're scaling it, we're multiplying it by 1 over n minus 1. We'll go through an example in a little bit, and I'll show you how to do that. But once we get this value out, as I told you, it goes between -1 and 1. So how in the world do we interpret what R is trying to tell us? Well, as you can probably imagine, the closer we are to a -1 and a +1, the stronger the association. So the closer we are to a -1, the stronger the negative linear correlation association. The closer the correlation coefficient is to a +1, the stronger the positive association is. Okay? So in general, and this is not a hard, steadfast rule that you should always follow, but just in general, if your R is greater than a 0.75 or a 0.8, something like that, if your R is bigger than that, then that's close enough to +1 where we say we have a strong positive linear association. Okay? If your R is less than a -0.75-ish, -0.75, -0.8, if you're smaller than that, then we say the variables have a strongly negative linear association. For any R values that are close to 0, right? So something like a -0.1 or a positive 0.2. Those values that are close to 0 on either side, negative or positive, we say the variable has no linear association. Okay? And then we have kind of like these intermediate weak zones as well, right? And once again, this is not a rule that is, standard. This is just something that I just kind of observed. But R values between 0.3 and 0.7, we say that they're positive linear association, but they're weaker than ones that are, say, greater than a 0.8. And same thing for the negative values. If you have an R value between -0.3 and -0.7, we say the variables have a weak or moderate negative linear association. All right? So what that means, if we go back to our graphs here, our scatter plots, right? So something like this no association, this graph E here, this would have an R value that is close to 0. That's how you interpret that, because there's no association here, so the R value is going to be close to 0. Whereas something like graph C would have an R value that is close to +1. Why is that? It's because we see that it has strongly positive association there, correlation there. And whereas something like D would have an R that's between somewhere between a 0.3 and 0.7, I would say. Why is that? That's because we have positive association there, but it's weaker than what we see in part C. And we can make the similar analogies for part A. Part A would have or graph A would have an R value close to -1, because that's a strong negative association there. And in this one, we have an R between -0.3, let's say, and a -0.7. Actually, let's go in actual correct order here. -0.7 and -0.3. Okay, so I hope that shows you guys kind of what that R is interpreting for us. Okay, so lastly, we're going to wrap this up by, you guessed it, we're going to calculate the correlation coefficient. So is there an association between age of a person and number of hours they sleep per night? Calculate the correlation coefficient for the following data set and determine what type of association the data exhibits. So first of all, this is data that I completely made up. This isn't real data, but we have two variables. We have age and we have hours of sleep. Okay. When it comes to correlation coefficient, it doesn't matter what you call X and Y, but I'll just call age X and hours of sleep Y. And what we're going to do is we're going to calculate R. Okay. And R is 1 over n minus 1 times the summation of x sub I minus x bar over the standard deviation of the x's times yi minus y bar over the standard deviations of the y's. Okay? Well, before we get into crunching these numbers, let's take a look at the scatter plot for this. So in order to do this, I have loaded all of our data here into StatCrunch. Okay, so let me show you how to calculate a scatter plot. So it is a graph. So we go to graph and we go to scatter plot. Okay, let's make this a little smaller. All right, so the x variable, they want to know what are your x variables. So our x variable is age. So I'm gonna select age. My y variable is hours of sleep. And that's it, folks. That's all we really have to do. We just want a basic scatter plot here. Okay. So let me go down here to compute. And boom. There we have. So we have, well, obviously because we're going to do this by hand, there's not really a lot to glean from this. If we had more data points, we could start to see more of a pattern here. But it appears that as age increases, the number of hours of sleep are going down. So it appears that there is some, in fact, pretty strong negative linear association here. So let's quantify that effect. So here we go. So for the formula, we notice that we need the means and the standard deviation. So this is what we're going to do. We're going to use StatCrunch to calculate x bar, the sample standard deviation of the x's, and then we'll also do the same thing for the y variable, y bar, and the standard deviation of the y's. To do that, let's get rid of our graph. All right, so to calculate those summary statistics, we go to stat, summary stats, and we go to columns. Okay, because our data is located in columns. So I can bring that over. All right, so we want to do this first of all for age. Okay, and then, okay, let's move age over. And then we want to, what statistics do we want to calculate? We're really only interested in the mean and the standard deviation. So I'm going to uncheck these. You don't have to do this, but I just want to uncheck those. All right, come over here to items, select mean, standard deviation. That's what I want. I guess I could have done it that way. All right, and then we compute. And there we go. The mean age, remember this is the x value, so the mean of the x variable is 25.5 and the standard deviation is 10.66. All right, let's do the same thing for the y variable. So I'm going to come here, go back to my summary stats, columns. This time I want to do it for, let's move hours of sleep over. Okay, that's my y variable. And then I want just the mean and the standard deviation. All right, we calculate that. Well, it gave me a bunch of stuff, didn't it? All right, so the mean is 7.5. The standard deviation is 2.38. All right, now that we have that, we are able to go through and do the correlation coefficient. Okay, so R equals 1 over n minus 1. So it's going to be 1 over, there are 4 ordered pairs. 4 ordered pairs. So my n is 4. Okay. All right, so 1 over 4 minus 1 times the summation. So I'm going to do this. I'm going to do a bracket. Times the summation of xi minus x bar. So what I do is I take my first x value, which is 37, minus the mean of the x values, which is 25.5. And I put that over the standard deviation for the x variable, which is 10.66. Okay? And then this thing gets multiplied by the y stuff. Meaning I take my first y value of 6, that's the number of hours of sleep, minus the mean for the y variable, which is 7.5, over the standard deviation for the y's, which is 2.38. Okay? Plus, now I move over to the second set of values. All right, so that would be my x value is 15 minus my x mean is 25.5 over my standard deviation of 10.66 times now the second y value is 9 minus, let's see, my y bar is 7.5 over 2.38 plus, I'm going to come down here, I'm running out of space. The third x value is 18 minus 25.5 over 10.66. Hoping you guys are seeing the pattern now. Times 10 minus 7.5 over 2.38. And then lastly, plus the fourth order pair will be 32 minus 25.5 over 10.66 times 5 minus 7.5 over 2.38. Okay. All right, close bracket there. So what we're going to do is we're going to put all this into the calculator, and then that's going to give us our R value. Okay. All right. So what I'm going to do is I'm going to do this off camera, and then I will be back with you guys in just a second. So what we see here is I've gone ahead and I've worked inside the brackets there, and I got a negative 2.68. So our R value, our R coefficient is going to be a negative 1/3. That comes from the 4 minus 1 times, what do we say, a negative 2.680. Which gives us, let's see what that equals. So we'll take a negative 1/3, multiply that, or excuse me, a positive 1/3. So 1 divided by 3 times a negative 2.680, and we get a negative 0.893. So yeah, we have what type of correlation here? What type of association, I should say? We have a strongly negative linear association, because that R value is really close to a -1, and that's kind of what our plot had showed us. Okay, so listen, y'all, I do not want you doing that by hand. This is how you do it in StatCrunch. So let me show you how to do that. So in StatCrunch, let's clear this out. What we're going to do is, let me bring my mouse over. We are going to go to Stat, okay? And then we're going to go to Regression. We'll talk more about this in the next video, but go to Stat, Regression, Simple Linear. Simple Linear. It's going to bring up this for us, okay? X variable, that was our age. Y variable, the hours of sleep. And notice it's asking, don't worry about what we're performing. We're not going to perform nor a hypothesis test nor a confidence interval. So it doesn't matter what that's on. So let's keep on scrolling down. Let me make this smaller for you guys. All right, let's go down to compute. And what's going to happen is they're going to give us a lot of information. But for right now, the only thing that you guys need to be concerned with is R, the correlation coefficient. Let's see if I can highlight it. The correlation coefficient. And there we go, folks. It's a negative 0.893, which is precisely what we got by hand. So the moral of the story is put this in the calculator, in StatCrunch, because we're not going to be doing this by hand. Anyways, guys, I think that's it for this video. I appreciate you listening in, and I hope to see you in the next one. Take care.